Okay. A certain metal has a work function of 3.06 exponent negative 19 joule. Light with a wavelength 450 nanometer shines on the surface of the metal. What is the threshold frequency? Calculate the kinetic energy of the ejected electron. And what is the speed of this electron? Okay, for question A, threshold frequency. The question asks for F naught. So we use the formula W naught equal to HF naught. So W naught is the work function. We just plug in the value 3.06 exponent negative 19 joule. The Planck constant H 6.626 exponent negative 34 joule second. Then F naught. So do your maths and you get your threshold frequency 4.62 exponent 14 Hertz. Now let's move on question B. Calculate the kinetic energy. So we can use the formula E equal to K max plus work W naught. Okay, so we substitute E here as Hc over lambda minus W naught. So just plug in all the value. H is Planck constant 6.626 exponent 34 times 3, the speed of light, 3 exponent 8 over lambda 450 nanometer. So we change into exponent negative 9 meter minus the work function 3.06 exponent negative 19. So do your maths and you will get 1.357 exponent negative 19 joule. Okay, for the last question, C, what is the speed of this electron? So, to find the speed, just use the formula of kinetic energy, K equal to half mv square. So, V, you get 2K over m, and you set. So, plug in all the value, 2 times the kinetic energy that you get just now, 1.357 exponent negative 19 over m is the mass of the electron, 9.11 exponent negative 31 kg. Okay, kg. So this one in joule. So set, don't forget the set. And do your maths, you get 5.46 exponent 5 meter per second. Meter per second. Okay, let's try another question. Okay, for this question, the diagram shows an experiment to study the variation of photoelectric current with the potential difference supplied. So the monochromatic radiation used has a wavelength of 400 nanometer. Okay, so the variation of the current I with the potential difference V is shown in the graph. Here is the graph. So the question said, copy the graph and sketch additional graph to show variation of photoelectric current with potential difference if light intensity is increased for the same monochromatic light. And the second one, light frequency is also increased, but the intensity is kept the same. So we need to draw and copy the graph first. Okay, for the first question, one, the monochromatic light is the same. So when the light intensity is increased, the number of photoelectron emitted per second also increases. So the incoming wavelength remain the same because we use the same monochromatic light. So the maximum kinetic energy will remain the same. So for a new graph, we will get the increase I, but the stopping potential Vs will remain the same. So this is for number one. For the second one, light frequency is increased, but the intensity is kept the same. So when the frequency is increased, the maximum kinetic energy of the photoelectron ejected will be increases also. So the value of Vs will increase. The graph will be like this. Okay, it should be a straight line. This is the graph for second one. So this is how you sketch and draw the graph. Thank you for listening. Till we meet again next time. Thank you.